Hello mathematicians, today's objective is objective 155, and this video is only on part 1 of objective 155. So go ahead and get that down. And today's objective is students will be able to understand and name polynomials. Students will be able to understand and name polynomials. Okay. Alright, let's just get started with some vocab words real quick. The first vocab word is obviously this one. What is a polynomial? Well, don't be scared by the name. We've actually been working with these already a lot this year. When you think about our terms, like with combining like terms, when you think about our exponents unit, we've already been working a lot with these. Okay, a polynomial is simply a monomial and again, I hate when they kind of use these big words in the definitions. Okay, all a monomial is a term, and we're going to go over some examples of these in a second. So a polynomial is just a monomial, which is a term, or a sum of monomials. Okay, so get that down. Okay, next vocab word we're going to do is, let's see if it'll change slides here. Okay, our second vocab word is monomial. Okay, a monomial is this, and again, I'm going to use a bunch of technical words so that we have the exact definition, and then I'll obviously break it down for us so that we have a much better understanding of what it actually is. But a monomial is a product. Okay, product of numbers and or variables with whole number exponents. Okay, get that down, then I'll break it down for you a lot more. Okay, again, if you're not done, just hit pause, but I'm going to keep us moving. Okay, a monomial, you guys, is simply this. It's simply we've been talking about a lot, it's simply a term. Okay, whenever we talked about like combining like terms, these are simply terms. Okay, let me give you a few rules that are incredibly important. Okay. First thing with a monomial is you cannot have no division of variables. This is kind of rule number 1. So I'm going to give you a few rules on what monomials can and can't be. Okay. Number 2 is no negative exponents. Okay. Again, we'll go over some examples, but no negative exponents. Okay. Third kind of rule that we oftentimes see, again, these are things that make it not a monomial anymore, is no just addition or subtraction of variables. Okay, no just addition or subtraction of variables. Okay, all right, now let's apply some of these rules. Make sure you have, I would say, about 8 to 10 lines. Book still, if not, turn the page, because we're going to set up kind of a T-chart of what monomials are and what not a monomial looks like. Okay? Let me give you a few, and then I want you guys to tell me. In fact, I'll give them to you right down here. Don't write these down yet. I just want you to be able to think about these. Let's start with this one. Negative. Again, you're not writing this down yet. You're just watching. And then you'll be able to write this in a second. Negative 8x to the third power, y to the first power. Okay. And my question is this a monomial? Okay. Well, if we think about it, let's apply the definition now. Our definition was a product. Okay. Well, what does product mean? Multiplication. What does it mean if I have numbers and variables touching each other? Well, I know that that means multiplication in between. So product of numbers and or variables with whole number exponents. Are these whole number exponents? So far, yes. Now, let's look at our rules. No division of variables. Am I dividing variables? Answer, no. Do I have any negative exponents? Answer, no. Okay. Do I have just addition or subtraction of variables? No, I don't have any addition or subtraction. So this one, okay, and the other thing to think about, it's just a term, right? This whole thing right here is just a term. That's it. Okay, so this one is a monomial. Negative 8x to the, and you guys should be writing this with me now. Okay, y to the first power. Okay, so that one was a monomial. All right, I'm going to erase this down here, and I'm going to give you another one. Again, you guys aren't going to write this until we determine whether it's a monomial or not. Okay, let's do, what if I just give you x? What is x? Okay, well, what's in front of x that's actually hidden there? And you should be saying, oh, hidden 1's there. Okay, what does it mean if I have a 1 touching a variable? Well, that means multiplication, obviously. Okay, do I have any division of variables? No. Do you have any negative exponents? No. Do I have just addition or subtraction of variables? No. So this one, x, is a monomial. Okay, so make sure you get that down. And if you have any questions on these about why one is a monomial or not, make sure you put it like a circle that one and write a question mark. Like, why is this one a monomial again? And then when we get to class, you can ask it. Okay, let's say I give you this one, 5n to the negative 2. Okay, well, let's apply the rules. Is it the product of a number and or variables? And the answer is yeah, these are touching, so that's product, that's multiplication. Okay. Do I have division of variables? No, the answer is no. Do I have negative exponents? The answer is yes, there's a negative exponent. So that means, because it has a negative exponent, that this is not a monomial. Okay? And here's where good note-taking comes in, so that you remember this. Put a note right here and just say no negative exponents. Okay, again, this is just good note-taking that you guys should be doing on your own without me having to tell you. All right, let's do another one. Let's do C over D. Okay, now let's look at this. Is this the product of numbers and or variables with whole number exponents? Answer, well, the division, this fraction bar means division, right? And we have right in our rules, our first rule was no division of variables. Okay, so this one is clearly not a monomial. And again, put a note here and say something about no division of variables. Again, you guys can write that in your own words. Again, just put a note, no division of variables. Okay, let me give you another one. This one, number 5. Number 5. Okay, this one is actually really, really tricky. If you go through all the rules, okay, no division of variables, no negative exponents, no just addition or subtraction of variables, you'd say, oh, well, you know, it's not in that. But then you look at the monomial, it says a product of numbers and or variables with the whole number exponent. Okay, I'm going to just tell you on this one. The number 5 is actually a monomial. And here's why. And it gets kind of silly about why they call it a monomial. But the reason why is because I could multiply 5 by any variable, and any variable that's not actually there is raised to the 0 power. Okay, and I know that's weird because a to the 0 power is 1, right? So I could just say, oh, that's 5 times any variable raised to the 0 power. Yeah, then you get back to that's multiplication. The main thing on this is it's kind of one of those, at least for me, that I just kind of have to memorize that any number is actually a monomial. It is a term. Okay, and again, I would put a note and just say something about like numbers alone are monomials, and I'm going to abbreviate. Okay, and we can talk more about that in class. I can give a little bit deeper explanation, but it's kind of one of those things where we just have to memorize that numbers are actually monomials. And to me, at least, it doesn't seem like they should be given the rules, but they are. Okay, let me give you a few more. A, B, C squared over 5. Okay, I'll give you a few seconds. Think through, look through your definition, think through your example or your rules, and determine, is this a monomial, or is it not a monomial? Okay, take about 5 seconds. Okay, the answer to this one is that it is a monomial. Okay, and here's why. I mean, if you look at the rules, one thing that I could do, and I want you guys to go ahead and write this up here now, A, B, C squared all over 5. Okay, and the reason why is this. Because we could write this as 1 over 5, but we could write that 1 over 5 out in front. Okay, and then you're still just multiplying 1/5 times A. Okay, just because it's over 5, again, that's the same thing as showing 1/5, which is a number, right? 1/5 times A, B, C to the second power. So let's just write that. That way remember that. Again, the main thing is it can be written differently. Okay, and then our rules all apply. We're not dividing by a variable, we're dividing by a number, and that's a lot different. Okay, so if you're looking at your rule saying, oh, you can't divide by a variable, it's not a variable. 5 is not a variable, it's a number. Okay, let's just do 2 more quick ones. 8 to the third plus 5a to the negative 2. Okay, what are your thoughts on this one? Well, you should be saying right now, negative exponent cannot be. Okay, so add this to the not a monomial column. That's 5a to the negative 2. And again, if it were me, I would put a note that says something about no negative exponents. Okay. Again, if you have any questions on these, make sure you write a question mark, write out what your question is. That way when you get to class, you can ask right away. Last one, P plus Q. Is this a monomial or not? And the answer is no. Okay, it is not. And again, we already had in our rules, we said no just addition or subtraction of variables. Okay, if we go back to like our combining like terms objective way back when, okay, we could write it like this, right? And then what would we do before the addition sign? We would put a plus bar, separating one term from the other term. Okay, so we're going to learn coming up that this is 2 terms. It's not a monomial. Okay. Okay. So, and you could have actually, if it were me taking notes, I would just write that as P plus Q. Okay. All right. So those are some examples of monomials. Again, monomials are just single terms, just terms. That's it. Okay, so far I have been throwing out the word monomial around a lot, and it sounds similar to polynomial, but it's a little bit different. Let me break down some more vocab for you, and I think this graphic organizer will really help. At least it really helps me understand what all these words are. Okay, polynomial. Okay, here's the ways to think about a polynomial. Okay. There are different types of polynomials. One type of polynomial is and we've already been talking about this, monomial. This is just one type. Okay? Now, mono. Think about what the prefix mono means. Okay? Hopefully you've learned from science or from some other classes that mono, okay, is singular. It means one. Okay? So monomial just means one term. Okay, let's do another one. Again, I think once I show it this way, it becomes pretty self-explanatory. Binomial. Binomial. Okay. All right. Look at the prefix in this. Bi. Think about a bicycle. How many wheels does a bicycle have? Okay, 2. So how many terms does a binomial have? The answer is 2 terms. Okay. Try. See how this is kind of making sense now? You're like, oh, that's not so hard. Trinomial. Okay. What does try mean? Hopefully you know try means 3. So this has 3 terms. Okay. Now, you guys should have more room on your paper than me, but you're going to do like a 4th one right here. Okay, and I'm just going to show it over here because, again, I'm out of room. You guys should have more room than me. If not, hit pause and rewrite it a little bit smaller across your paper so that you do have more room. The last type is polynomial. You may be thinking, well, that's the same thing as the name up above. Okay, here's a polynomial. Okay, just means that there are 4 or more terms. Okay. We have special names, like if it's 1 term, it's mono. If it's 2 terms, it's binomial. If it's 3 terms, it's trinomial. If it's more than 3 terms, we just call it a polynomial. We don't have a special name for it. Okay? All right, I want you guys to make sure that you have a full piece of paper. So if you've been taking notes on one page, turn to the next page, get down a full sheet of paper because we're going to start a table that we're going to fill out most of it today, and then on the next video lesson we're going to fill out the rest of it. Okay? So right now, flip to a new sheet of paper. I'm going to flip to a new page, and let's... Okay, here is our table. And you're gonna have 5 things going across the top, so make sure that you don't write too big. And I'm gonna try not to write too big either. Okay, so first one is expression. Okay, I'm gonna give you several expressions. Second thing is, and again, this is gonna go all the way across your guys' paper and all the way down, is the terms that it has. Okay, third thing is we're going to name it then. Oops, that's ugly. Okay, we're going to name it. Fourth thing, and this is what we're going to fill out tomorrow, but I want us to just get it in here right now, is degree of each term. And again, I'm having to write much bigger than you guys. Hopefully I have a lot more room than me. Last thing we're going to do is called the degree of, and I'm just going to abbreviate for polynomial. Okay? And again, these last 2 we're actually going to fill out in the next video lesson. But I want it all to be together. So let me give you a few expressions, and you guys are going to talk to me through the next few columns. So 2x minus 3yz. Okay. First of all, what are the terms? How many terms are there in this? Well, we know that terms get separated by addition or subtraction signs. This is nothing new. So how many terms are there? Well, there's 1, 2 terms. So let's write 2. And then let's actually list what they are. So the first term is just 2x. What's the second term? Don't forget it's negative 3yz. Okay. Well, if there are 2 terms, okay, 2 terms, right? What's the name of it? Write it in. Make sure you're using a pencil. What do you think the name of it is if there are 2 terms? The answer that you should be writing right now is binomial. Okay, bi means 2. Okay. I'm going to keep going through several examples of these, and again, if you have questions on them, make sure you bring your questions to class. Okay, 8 n to the third plus 12 n to the negative 2. Okay, all right, let's see, how many terms are in this one? Well, we can separate with a plus or minus sign. All right, and then how many terms are there? Well, we have this term and this term. So that would be 2. What are the two terms? I'm sorry, I'm going to change where I wrote that. So we had two terms. What were the terms? Well, we have 8n to the third power, and then we have a positive 12n to the negative 2. All right, what's the name of this? Oh, you might be thinking, oh, there are two terms, right? So it's a binomial. Remember with their names, this one has a what? It has a negative exponent. Okay, what's the name if it has a negative exponent? Well, it doesn't have one of those names. The answer to this is there's not a special name for it because of the negative exponent. Okay, there's not a special name for it. All right, we're going to keep going. A few more examples. 8. What if I give you 8? Okay, well, how many terms are there? One term. Pretty simple. Oops. I don't need to write the word term, do I? I just can write one term. Okay, what's the name of it if there's one term? What prefix means 1? You should be saying monomial. Getting sloppy. Sorry. Monomial. Again, we're going to fill out those last two columns tomorrow. Or on the next video lesson, which hopefully you decide to watch today. Alright, let me give you another one. I'm going to tell you right now, this one's a little bit trickier. And you're going to say, no, it's not. Trust me, it is. Plus 5a plus a. And then plus 9. Okay? And you might be saying, oh, this isn't hard. Watch this. I'm just going to separate the terms. And then I'm going to put that 1 in there. I'm even going to remember that hidden 1, because if I don't, I know it messes me up. And you're going to say, oh, there are 4 terms. Okay. No, there's not. And here's why. And again, this is why it's a little bit trickier. What can you do with these two terms? The answer, you can combine them. So when you combine them, you're going to get 4a squared plus 6a plus 9. Okay? Now, can you combine any more? The answer is no. So how many terms does this one have? The answer, there are 3 terms. We have a 4a squared, we have a 6a, and we have a 9. If there are 3 terms, we call it a trinomial. Okay, trinomial. Okay? All right, I'm going to give you guys several more. Actually, just a few more. Let's say I give you, I'm just going to give you the trickier ones, because then we'll practice some more of the basic ones in class. Let's say I give you 3, I bet I get you on this one too. 3a plus 7ab plus 2a squared b. And you're really going to have to bear with my sloppy writing. Again, this is 2a squared b. And then I'm going to have to go to the next one. Plus ba. Okay. Well, first thing you should always look to do is see if you can simplify. And this one's really tricky because we can actually simplify. I'm going to separate my terms. There's a plus. Okay, can I combine any terms? You may be saying, no, you can't combine any terms. What about these two? Okay, including that plus sign. You might be thinking, no, because Mr. Irwin, this one's AB, this one's BA. What property is it where with multiplication we can change the order? The answer, commutative property. These two are like terms. We can rewrite them. So it would be 3a, a 7, and a positive 1 would be plus 8. And I'm going to put them in alphabetical order now. And plus 2a squared b. Okay, so how many terms are there here? There are 3 terms. What is this called? If there are 3 terms, it is called a I'm just going to abbreviate, trinomial. Okay. All right, last one. I'm actually going to do it over here again because I'm out of room. You guys should have plenty of room on your paper. What if I give you 1, and again, you guys are writing this example right down here. but the example is 1 over 4y squared plus 5x. Okay, what is this one? Now, this one's kind of tricky. It looks like this y is positive down here, right? Because it's a positive 2. But in order to put that in the numerator, because right now it's in the denominator, right? In order to put that in the numerator, how would we have to rewrite it? Well, one answer would be 1/4, and then that y could be written to the -2 on top, because when I know it's -2, right, I know to get rid of the -2, I'd have to put on bottom where it currently is. Okay, so this one, because it has a negative exponent, and I know you think, oh, it's on bottom, it's not negative. Well, if you put it normally, right, in the numerator, it would have a negative exponent. So the answer to this one is, it doesn't have a name, again, because if we go back, negative exponents, we don't name them with a polynomial name. So the answer to this one is just no name on it. Okay? Okay, that concludes part 1 of this objective. The next video is going to be part 2, and that's where we're going to be talking about degrees of polynomials and putting them in the correct order, which we've kind of been working with, but it gets a little more complicated as we get into the more algebra 2 type expressions. So again, make sure you watch part 2 of this objective and to learn about the order and degrees of polynomials.